Okay, so let's go ahead and let me go ahead and share the screen. All right, let's go ahead and get those problems written down. Okay, did we get it down?
Yes.
Okay, so let's go ahead and take a couple minutes. Let's take 5 minutes to try and solve those problems. Okay, so give them a shot. Uh, or maybe like 3 or 4 minutes. So try to go ahead and do those, and then we'll go over them. Okay, so let's go. Let's take a couple minutes. So I guess back at 11:16. Yeah, we'll start that. So I see 11:12. So 11:16. Let's go ahead and try to work those out. Okay. Okay. So let's go ahead and go over them. Two over 3 divided by 7 over 5, right? What do we get for this one? What do we get for this one? Anyone have the answer?
Aren't you supposed to like keep change and flip, correct, Ms. Rodriguez?
Yes.
Okay.
So 2 over 3, and then we're going to multiply by what?
5 over 7.
So what would be the answer there?
10 over 21.
That's right, 10 over 21. Now the question is, can we reduce that?
Yes.
Are we sure?
No.
So let's just
No.
think if they have any factors. So we can divide 10 by 2, and that's 5. And we can divide 21 by 3, and that's 7, right? So do we have any common factors there?
No.
No.
Oh, right? And there's none of them are matching. So if that's the case, then that means that it'll stay as 10 over 21.
Okay.
Okay?
Yes, sir.
What about the second one? 4 over 5 divided by 11 over 7. So 4 over 5 divided by 11 over 7.
It's going to be 28 over 44.
28 over, actually 55, right? So remember, the reciprocal is 7 over 11.
All right.
And we're going to multiply it straight across. So that's 28 over 55. Right?
Mm-hmm.
Oh, dang, I put a 4 instead of a 5. My bad.
Yeah, so, or I guess you just multiplied the 4 and the 11, right? So just make sure, yeah. Now the same thing, right? If we compare the two, it's 2 and 14, 2 and 7, and we have 55 can be divided by 5 and 11. Do we have any matching factors there?
No.
Yeah, we don't have, we don't, right? So can we reduce this?
No.
No.
Right? So we just leave it as 28 over 55. So I guess just as important is knowing not when to not reduce, right? When do we not reduce? It's just as important as knowing when to reduce, okay? And this last one should be a little bit easier in that sense. Let's see, it was 13 over 10 divided by 8 over 3. 13 over 10 divided by 8 over 3. So what would we have for this one? 39 over 80.
39 over 80.
39 over 80. Good. So 39 over 80. Again, if we compare 39 over 80, we can divide 39 by 3. That's 13. And we can divide 80 by 2, that's 40. Then again by 2, that's 20. Again, that's 10, 2, and 5. So it's quite a bit of factors, right? But Do any of them match, right? Do we have any 3s or 13s there that match?
No.
Nothing at all. So again, we do not reduce this fraction. It stays as 39 over 80. Okay, all right, pretty good. So what we're gonna get into today is adding and subtracting. Now, the reason why I start with multiplying and dividing is because those are a little bit easier, right? Can we agree that those are multiplying and dividing fractions is easier? Or not that it's easier, but it's at least pretty easy thing, right?
Right.
So when we're adding and subtracting fractions, what is the most important thing that we need to look out for? If you guys can remember. So for example, let's say I have 3 over 8. I'm going to add 4 over 8. Because the better question is, can I actually do that? Can I add those two together?
Yes.
Yes? So what would the answer be there? Are we sure about that? Remember I said, there's one very key thing that we are looking for. Do we have any idea what it is?
A common denominator?
Sure, the common denominator. We want to make sure that the denominators are the same, right? So in this case, are the denominators the same?
Yes.
They are, right? So that stays the same, and then we can just add the top two numbers, 3 plus 4. So what is that? What is the answer there? So 3 plus 4, that would be what?
7.
7. So the answer we end up with is 7 over 8. So again, all we did was look at the common denominators, make sure that they're the same. And so if that's the case, then we can just add them straight, 3 plus 4, okay? So I want you guys to think about this visually, okay? So what I'm gonna do is I'm gonna draw out our circles again. Now, if you remember, what does the 8 represent in the fraction? Can anybody remember? What does that 8 represent? Remember, that's however many slices we're gonna split the circle up, right? So in this case, we have 8, right?
Right.
So 3 tells us that we fill in 3 of those slices, right? And a 4 tells us that we're gonna fill in 4 of those. Okay, so visually, you guys can see, okay, like, so I have 3 of 8 on one side and 4 of 8 on the other. So if I put these two circles together, what happens? We are going to fill in all the ones. So 3 here and 4. And so in total, we have 7 out of the 8 slices filled in. Okay, so that's what we just did with the fractions, right? So
Yeah.
we just made sure that they're all, like, we put them together and we just said, okay, we have 7 in total out of the 8. So it's not too difficult, right? This shouldn't be too difficult at first, right? So we got this down. We good?
Yes.
Okay, just one more second. Okay. So as our first example, let's say we have 2/9, and we're going to add 4/9. So in this case, again, do we have are the denominators the same?
Yes.
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 So we can just add them together, right? So 2 plus 4, and then 9 stays the same. So what's the answer there?
6/9.
6/9. Now, can we reduce this?
Yes.
We
Yes.
can. By how much?
3.
By 3. There we go. So 3, 3. So 6 divided by 3, that means on the top we're going to have 2. And then 9 divided by 3 is 3. So our reduced fraction is 2/3. All right? Pretty good? Not too bad?
Yes.
Yes, sir.
Next example, let's say we have 7/10. Oh my goodness, 7/10, and we're going to subtract 3/10. So does this work the same when we're subtracting?
Yes.
It does,
Yes.
right? So make sure that, the denominators are the same so we can subtract. So what would be our answer there?
Four over 10.
4/10, that's right. 7 minus 3, that's 4, and then the 10 stays the same. Now, can we reduce this?
No.
No.
Are you sure?
Hey. Oh, yes, we can.
We can. So
By 2.
by 2, that's right. So let's compare. We can divide 4 by 2. We can divide 10 by 2.
Right.
So
So it's 2/5.
we have our factor there is 2. And what are we left
Right.
over is 2. And sorry, actually, I forgot to do that part.
Let's see.
There, right?
Right.
So we have a 2 and a 5 left over.
Mhm.
Right.
So we can divide by 2. So we have 2 and 5.
Good.
Oh, I see what I did there. Never mind. So I was kind of confused. Hold on. There. Now we're left over with a 2 and a 5.
Right.
Next, I was like, wait a second, what's going on there? Okay. So far, not too difficult, right?
Right.
Okay. But here's the next thing. Okay, here's the next step that we're going into. So now let's say I want to, let's say I want to do 1/3, and I'm gonna add 3/4. So visually, this is what we're doing, right? We have a circle with one of the slices filled in, and then we have another one with 3 of them. So the question is why? I mean, can we add this together? And if not, why? What do you notice about the circles, and why is it that we just can't add these 2 together?
The denominators are different.
Well, the denominators are different, but visually, what do we see here? Why is it that we just can't say, okay, you know, I have this part of a circle, I have this part of a circle, and I'm just gonna put them together? Why can't we do that?
Wouldn't it equal a whole?
I mean, if you think about it, right, like, I mean, technically, I guess it would equal a whole, right? But look at the slices, like pay attention to the slices, right? Like we set apart the 3 and the 4. Which one of the circles has the bigger parts or the bigger slices?
The 4.
Are we sure about
1/3.
that? Think about, like, yeah, think about it. Like 1/3 is a much bigger part of the circle than 1/4 is, right? So we just can't put them together. We will need to make sure that they're equal, like they're in equal parts, because we can't compare them when they're like that, right? So let's go back and say, okay, let me, okay, 1/3 plus 3/4, okay? So maybe you guys have learned a certain way. I learned a way that I think makes it a little bit easier. So hopefully you guys like that. But it takes 3 steps, okay? So first step, we are going to multiply the 4 and the 1, okay? So let's multiply 4 times 1. What would that give us?
5.
4.
4. We're multiplying. 4
Oh.
times 1. Next, we're going to multiply the 3 and the 3. So what that gives us?
9.
9.
9. Okay, finally, we are going to multiply these 2 on the bottom. 3 and 4.
12.
Okay? So we have 12. Now, doing that, our denominators are now the same. And now we can add 4 and 9. So what's 4 plus 9?
13.
13. So our answer, 13/12. Okay? So I found this to be a little bit simpler than, you know, past ways that I've taught this. So hopefully you guys think this is a little bit better. Can we
Where'd you get the
reduce?
12?
Sorry?
Where did you get the 12 from?
We multiply the bottom 2 numbers. So 3 times 4.
Oh, okay.
Okay? So can we reduce 13/12?
No.
We cannot. Now, there's a hint as to, there's one thing that should tell you that we cannot reduce it. One of the numbers tells us that we can reduce it. Which one is it and why?
12.
12 or no, not necessarily, right? What about 13? 13 tells us that we can reduce it. And why is that?
Because of the 3.
Because of the 3, but more specifically, what did we talk about yesterday? What is 13?
Oh, freak.
Remember we talked about it yesterday.
Composite number or something?
Not composite, but the other one, it's
Damn, hold on, let me think.
prime number.
Prime number, there you go.
So 13 is a prime number, so that tells us that we can't reduce it any further, okay? So that's like the biggest clue. All right, next example, let's do 5/6 plus 3/8. So let's try doing the same. Let's try doing the same process here. So first we're going to start by multiplying 8 and 5.
40.
40. Next, we're going to do 3 times 6.
18.
This is 18. And then we're going to multiply the bottom two numbers, which is 6 and 8. So then 6 times 8, that gives us 48. And at the top, we're going to have 40 plus 18. Okay, so what would the answer be there?
58.
58 over 48. And we can actually reduce this by 2. So 58 divided by 2, that gives us 29. And 48 divided by 2 is 24. So the answer, 29 over 24.
That's easy. Makes a lot of sense.
Okay. Okay, I didn't see that Haley was trying to get into the meeting. Let me just let them know that that we're almost done here anyway, so. All right. So works the exact same way as a subtraction. So we have the same steps when we have subtraction, okay? So let's go ahead and do that. Remember, what's our first step here?
To multiply.
Which numbers are we going to multiply?
5 and 4.
So 5 and 4, which would give us
20.
20. And then next ones are
18.
3 and 6, right? So that gives us 18. And then we are going to multiply the bottom two numbers. So 6 times 4, which is
24.
24. And then we have 20 minus 18.
Minus 2.
2. So 2 over 24. Can we reduce this?
Yes.
We can by
2.
By 2. That's right. So we divide both of these by 2. So 2 divided by 2 is 1, and 24 divided by 2 is 12. Okay? So pretty good. You know, I thought that, again, I thought this way was a little bit more, a little bit better, a little easier, just following those 3 steps. Okay?
Okay.
Okay, so let me see. Okay, so we've pretty much been able to get over. Again, I'll post this video on Google Classroom, you know, in case you guys missed anything or whatever. We've pretty much gone over everything that we needed to get over, needed to get done, okay, for these first 2 weeks. We are going to we're going to have we're going to have work on Google Slides again. So again, I want to make sure that you guys are showing the process, okay? So make sure to show the work, and so I can see that we are doing well with the process, okay? So the homework's on Google Slides. So we've gotten over everything that we needed to go over for these first 2 weeks. So we're not gonna have a meeting tomorrow or Friday, okay? We're just gonna leave those open so you guys can finish anything. I think you guys have pretty much done everything, but just in case, I wanted to make sure that you guys are done with the work for this week and make sure it's turned in on time on Friday, okay?
Okay.
Otherwise, let's see, what else?
What's the title of this? Oh, these examples and everything, Mr. Rodriguez.
Just adding and subtracting fractions.
Okay. Thank you.
Okay. All right. So, yeah, I think that should be it. You guys are doing a pretty good job. So keep on doing that. And if you guys don't have any questions, I think that is all. Okay. So I guess I will see you guys on Tuesday in person.
Okay.
All right.
Let's go.
Okay, guys.
Have a great weekend, Mr. Rodriguez.
You too. Bye-bye.
Bye.
Now.